The space-time relationships, cause of motion, only represent the motion of a body. Now in kinetics, we will concentrate the kinetics of a particle, point mass, or a rigid body. So with this, now let us concentrate what are the outcomes, learning outcomes. Before that, if you can see the syllabus for both the civil and the mechanical engineering. Yesterday we have discussed the kinematics of a point mass and a rigid body. Today we will discuss the kinetics part. This part, in that we have a like Newton's law, D'Alembert's principle, impulse moment, work energy, etc. Whereas if you see the mechanical engineering syllabus, kinematics and dynamics of a particle. Kinematics yesterday we have discussed. Now today we are going to discuss the dynamics of a particles and a rigid body in a linear, angular and a plane motion, a combination of translation and rotation, etc. We have to concentrate like Newton's laws, D'Alembert's principle, moment impulse, work energy methods, impulse moment, energy formulations. Okay, these are the things what we are going to discuss for a civil and mechanical cases. With this, now let us see what are the learning outcomes. Kinetics of a particle or a point mass, the number of particles. Point mass means negligible dimension, rigid body. Here we will represent or express dynamics of a particle or rigid body and differentiate between kinematics and kinetics. Then recognize and apply the concepts of different dynamics of dynamic principles. Recognize and apply the concept of different dynamic principles. Then derive an expression, Newton's law, momentum impulse equation, work energy by using these are the principles. And D'Alembert's principle, etc. These equations we have to represent different types of motions. There is translation, again rectilinear translation, curvilinear translation, rotation, plane motion of a particle and rigid body. The concept must and should understand by a good student and apply to any physical system. If you understand the concept without any difficulty, you can extend for any system. Because we are considering only a particle or a one rigid body. But if you take a system, it consists of number of rigid bodies. In that, rigid bodies are there, deformable bodies are there. If you can take a duster, one part is made with the wood and another part made with the foam. Foam is the deformable. The wood part is the rigid nature. Okay, this is how we will consider. We have to concentrate on then we have to update your knowledge of force as per the need. So now let us see today dynamics. What is basically definition? It is a kinetics part we are considering. In kinetics, study of relations existing between the forces acting on a body, the mass of a body, and the motion of a body. Forces acting on a body, mass of a body, and the motion of the body. It is used to predict motion which is caused by given forces or to determine the force required to produce a given motion, vice versa condition. Or in other words, it is the analysis of forces which causes the motion. You can represent in any form. Causing the motion, third and fourth are almost same, which is the analysis type of force causing the motion. It is a study of force as it works on a rigid body in motion or a particle. Once again, the repetition, it can be considered for a translation, rotation, and the plane motion. Okay, this is how generally we will try to consider the concepts. This mechanics is generally classified into, we already discussed, but brush up your knowledge a little bit, because introduction part, if you can recollect the things, it is easy. Statics. In statics, we only consider the different types of force system, draw a free body diagram and apply it to a particular system. Depending on the system, draw a free body diagram. Force, we already discussed all classification, concurrent, parallel, non-concurrent. Application part, we will consider the trusses, centroid of a cross section, friction, etc. Dynamics, we will consider kinematics and kinetics. In that again, both the cases, translation and rotation, a combination of translation and rotation, that is what we are representing here, the plane. Hello, sir. Sir, 12:30 there are quarantine. So now, this mechanics is further classified into statics and dynamics, kinetics and kinematics. Today we are going to concentrate this part, dynamics and kinetics. Okay, this we already completed, now we are going to consider this part. Little bit of plane motion we have to discuss, like instantaneous center method in this, but the remaining all completed. In here we are going to concentrate this domain today. This slide I already shown yesterday. Now let us see the particle and the rigid body. What is the dynamics part? Earlier we are considering only motion, like S is equal to ut plus half a square if it is a rectilinear motion, curvilinear motion in terms of theta, omega t plus half alpha t square. Like that we have considered. Now here in a particle we are assuming size is negligible compared to motion. All force must and should act through the center of gravity. Neglect rotation about center of gravity. This is where the total weight is acting, the driving force or any force if you can consider. This is what is the force, weight acting downwards, normal reaction. The vehicle is moving in this direction by applying an accelerator or decelerator, etc. That is the force. Assume that all force acting to the center of gravity, neglect rotation about the center of gravity, only considering a translation. Now rigid body is also same thing. Now here what we have to do, if you want to consider this body separately, then this is one reaction, this is the second, and this is the fourth. Here no only translation, here we are considering rotations. Translation part, if you can include rotation and moments about center of gravity if you want, you can take. Now this slide also shown yesterday only to differentiate the kinematics. This is the kinematics part, kinematic quantities in angular motion and linear motion. Now same two types of motions today in kinetics we are going to discuss. This is the scalar notation and this is the vector notation. Okay, for a two-dimensional cases. So now let us see the kinetics part. Rigid body in a planar. Because planar means you have 3 degrees of freedom. In a static condition, what we have done is sum of the force 0, sum of the moment 0 about one axis or moment about other axis, and sum of the force in y direction 0. X means x and y. Now instead of 0, now in the dynamics we have to consider the mass and acceleration. This is what is called the Newton's laws. Sum of the force, the resultant force is equal to mass into acceleration. Sum of the moments is equal to the mass moment of inertia into acceleration due to gravity. That is the angular acceleration. In MG, MA, MG, linear case, MG I alpha is the rotational case. Both are these two are Newton's laws. Second law. This is also Newton's second law. But translation case, resultant force, and rotation case to moment, resultant moment is equal to mass into linear acceleration. This instead of mass moment of inertia into angular acceleration. See, this is how generally we'll try to consider. This unit is Newton meter, this is a Newton. Mass is in kg, acceleration meter per second square, this is kg meter square, that is mr square. Alpha is radians per second square, this will get Newton meter. Those are the units. This is about center of gravity, this is about rotating axis. By parallax, any other axis you can determine. Or once we know the center of gravity, mass moment of inertia, you can, by using a parallax theorem, you can find out transfer from one axis to other. Or if you want, you can include the radius of gyration. This is for concentrated mass and this is for generally the distributed masses. So that's why here mass is one parameter we are considering. What is the force acting and what is the acceleration? Okay. This is how generally we will consider the cases. Translation, rotations, a combination of translation and rotation. Now let us see the different types of dynamic problems. How generally we try to represent in dynamics. Dynamics is generally represented as simple harmonic motion, or it can be simple harmonic meaning acceleration is proportional to the displacement. That's the mx double dot is equal to x cos omega t. Linear displacement. Mx double dot is equal to the proportional to the displacement. That if we can proportional means if we can use a simple harmonic motion, x is equal to x naught cos omega t. X dot is equal to like that. If you differentiate, you will get the expressions. From that, if you can simplify, x double dot omega n square x. This is what the simple harmonic motion. We will see later in detail. Newton's law of motion. A spring force is acting. Mass is connected with the spring. When you are applying a force to the mass, spring force is acting opposite. That is the acceleration, mass in the acceleration direction. If the force is acting in the same direction, we have to consider the positive, otherwise negative. Okay. So now what we have to do when you are applying a force, the spring force acting is opposite. When you are applying a mass into inertia force, spring force is acting opposite. That's why negative. Mass and acceleration is equal to force in the direction of acceleration should be positive, otherwise negative. This is acting opposite. I will explain later with some more figures. And that is what the general Newton's laws. Divide both sides by mass and simplify. This if you can equate, omega square is equal to k by m, or omega is equal to square root of k by m. K is the stiffness, m is the mass. This is the k, stiffness of the spring. You can use energy method. Total potential energy is equal to kinetic energy plus potential energy of kx square, which is a spring, or mgh. The differentiate with respect to time is equal to 0. Then Rayleigh method. The maximum kinetic energy is equal to the potential energy gained by the system. Then D'Alembert's principle. You can solve the problem to convert a dynamic problem into a static problem. And we can consider. See, this is how generally we will try to consider the problems. Now compare with a linear motion and a rotational motion. Comparison of dynamic equation for linear and rotational. Newton's second law, F is equal to ma or mx double dot or w by g into x double dot. Torque is equal to I into alpha. That is mass moment of inertia into acceleration. And this is the momentum. P is equal to mv in linear momentum I omega. Work is equal to force into displacement. If you can integrate, this is for a particular, it is discrete and it is for continuous. You have to integrate. The like kinetic energy. Half mv square, m will be replaced by mass moment of inertia, linear velocity will be replaced by angular velocity. M linear, because Newton's law can be represented rate of change of momentum. Mx double dot, x double A is equal to x double dot, d square x by dt square. This can be written as if mass is constant, d by dt of m into dv. Acceleration can be represented d square x by dt square. 1 d by dt you can separate outside, m into dx dot dx by dt. dx by dt is velocity, mv. That is what is the rate of change of momentum. The in brackets term is called the momentum, mass into velocity. Mass will be replaced by mass moment of inertia, linear velocity will be replaced by angular velocity. Power is equal to Fv and that is the force into velocity. The cylinder I is equal to mr square. For a shell, it is thin space cylindrical shell, small thickness. This is R, and this is the solid cylinder. This is also half mr square. That is the difference between a shell and a cylindrical shell and a solid cylinder. Sphere is having 2 by 5 mr square. This is how to calculate the moment of inertia. The derivation part now we are not discussing because I is mass is we are considering when the body is in a rotation. When the body in a rotation, we are considering the mass of the body. That mass, it can be any body, any rigid body. It can be a cylinder, or it can be a sphere, or it can be a cone, or it can be a rod that is a thin rod. If the moment of inertia passing through the centroid, this is the equation. Or left hand and right hand. One end. You can consider either this or this. Okay. See, this is how generally we'll consider about this point or this point. Moment of inertia about the rod. Now these can be represented as Newton's 3 laws. This is already explained, but this is now what we are going to discuss is the exactly applicable to Newton's the 3 laws of motion. First law, this is the standard definition. Every body continues to in its state of rest or uniform motion unless there is no external force acting on the system. Or in other words, a particle originally at rest or moving in a straight line in uniform motion. It is not a non-uniform motion. Acceleration is 0 here, only velocity, no acceleration. That's why, in other words, it is equal beam of forces. It deals with the topic concern with the statics. No dynamics here. But what is the inertia is defined here, law of inertia. Inertia is also defined from the first law. So this is the limitation of first law. First law deals with when the problem is in statics. That means the body at rest, that is the velocity 0, or body in a motion, the motion is uniform motion, not a non-uniform motion. Please, this is very, very important point. The first law only deals with the static systems. That is equal beam of forces and statics. No question of dynamics here. Even the body is in motion, it is not due to the external force. Suppose I am giving a small example. A cylinder I am keeping on a plane surface. It is at rest. If the cylinder, if you can release from on an inclined plane, it is rolling. It is sliding. It is inclined is always the body is in the inclined plane. So this is what is called the Newton's law of motion. Newton's three laws of second law now. Here the acceleration of a given particle is proportional to the force applied. This is takes place in the direction of the, both are in the same direction. There is a straight line. Earlier the resultant force depend upon the type of force system is in the direction of velocity. See, now the force is proportional to the acceleration. It is an accelerated motion. The acceleration of a given particle is proportional to the applied force takes place in the direction of the straight line. Okay? A particle of mass m with an unbalanced force x have experienced an acceleration a that has the same direction of force proportional to the, that is directly proportional to the force, or the rate of change of momentum. This also can be defined. This is how the second law, it only deals with the accelerated motion, that is F is equal to ma, or A can be represented dv by dt, because if m is constant, d by dt outside, m into v, d by dt multiply both sides, f dt into m into dv, integrate, this is an impulse, and this is dv and integral will be cancelled, mv. This is the momentum, rate of change of momentum. Or F is equal to m into dv by dt, or d by dt take outside, mv. This is what is the rate of change of momentum. This is very, very important. As for the Newton's second law is concerned, we are concentrating on the dynamics. This is the exact principle what we are using as for the dynamic circles. Okay. So that is equal to F is equal to ma. The force is equal to mass into acceleration, or m in, that is a force is equal to m into v dot, that is the m into d by dt into mv, rate of change of momentum. Like that we can consider. Whether it may be rotation same, translation same, or translation again rectilinear, curvilinear, or a combination of translation and rotation. Okay. So this is how generally we will try to consider the cases. So now let us see the third law. Third law deals with the two equal and opposite forces, which are generally collinear. Is understanding of force always occurs pairs of equal and opposite forces. That is force of A and B. Action and reaction. So every action there is always an equal and opposite reaction, and the mutual action of any two bodies are always equal and opposite directed, oppositely directed. Now let us consider, and here important point is third law is valid for both the statics as well as dynamics. First law deals with only static systems. Second law deals with statics and dynamics. Obviously, by default, it is a dynamic, but purely a dynamic principle. First law purely static, second law purely dynamics. If acceleration 0, it is a static, it is first law, like that. No, if only velocity is there, uniform velocity, that too. Third law, for every action there is an always equal and opposite reaction is there. That is what is called the third law. Third law deals with both the static systems and dynamic systems. Let us consider here a block subjected to the applied force P. Fi is the force, and here actional, this is what is the Fi and P and the mu r. Mu is a coefficient of reflection. These all forces are given. Now actually this is an inertia force. Actually the direction of force is mass into acceleration. Acceleration is 2 mass into 50. This direction is actually in this direction. Now what we have to write? We have to write an equation. Actually here summation of force F is equal to resultant force is equal to mass into acceleration. This and this direction should be same. That means they are in the same direction. Suppose if I can apply Newton's law and D'Alembert's principle. Newton's law is this directly. What is the D'Alembert's principle is, which we are going to discuss in detail tomorrow, but I am giving a brief introduction here. The D'Alembert's principle is used to convert a dynamic problem into static problem. A dynamic problem can be converted into static. This equilibrium called the dynamic equilibrium. Dynamic equilibrium. Converting a dynamic problem into a static problem. Sometimes to simplify your problem. When you are converting dynamic problem to static problem, because this body is moving with an inertia force F I. Okay. Now to keep this body in equilibrium, this inertia force you have to apply in opposite direction. Same. Then the problem is instead of dynamics, it is statics. That equilibrium is called the dynamic equilibrium. That's what the inertia force is applied in the opposite direction. Now the system is in equilibrium. If it is in equilibrium, now the equilibrium equation only, that is sum of the forces in x direction 0. That's what this is the equation. Sum of the force in y direction 0. Because the body is having, it is a translation. It is only one direction. It is the another direction. Okay. We have to consider the body in this is vertical and this is the horizontal. Because it is moving, considering as a plane. Now see, this is P cos 45. This is one component. This is the second, sum of the forces. This is positive P cos 45 in this direction. This is in this direction. And this is opposite direction. That means this and this one both are negative and this is positive. So this is what a P cos 45 mu r into mass into acceleration. This is what is the mass 50 into acceleration 2. Mu value substitute 0.4, 50 into 2, this is one equation. P sin 45, this vertical component, P sin 45 and normal reaction. R is upwards. R. So now if you can count this, 0.4 into R. Okay. Now this is what is called the second equation. That is what is the second equation. P sin 45 upwards. R is also upwards. The weight is acting downwards. Mg. So that's why it is negative and this is positive. If I can write the same as per Newton's law, if I don't want to convert dynamics, then this is mass into acceleration in this direction. That is mass into acceleration is equal to the force in the direction of acceleration. This is one force. P cos (45). Because both are in the same direction. P cos 45. Then this is opposite. Mu r minus mu r. So now this is what this both are same basically. If you can move this into left hand side or this into right hand side, this equation will satisfy. Similarly, other reaction. No mass into acceleration in y direction. 0 is equal to upward force is P sin 45. P sin 45. So this is what is the upward, and R is upward plus R, and weight is downwards minus mg. The same equation you can see. See, that's why whether you can use a Newton's law, whether you can use a D'Alembert's principle, equations are same. Okay, the choice is yours. You can use the expressions as per your convenience. But here we are using a D'Alembert's principle. This is another dynamic principle which we are using to solve your problems. To solve your problems of some other force, this one. Even at the dynamics, to convert dynamic problem into a static problem. But the equation will be same. In detail anyway we will discuss further later. But here today we will concentrate on what are the dynamic conditions. Okay. Now let us start with the general motion in the two-dimensional case. How we are considering for a two-dimensional case. Here, force is equal to mass into acceleration. These two should be in the same direction. Okay, and these two should be in the same direction. Both are same. Only this acceleration A is equal to, we can write as x double dot like this, or we can write as d square x by dt square, or you can write as dv by dt. Okay, x double dot is an acceleration, x is the resultant force. So this is how generally we'll consider the motions. Both are in the same direction. You can represent in any form. The choice is yours. Okay, but these are the two standard ways. So like Tim Shankar and Singer and other books, they will follow this notation. Now let us consider an example. For the engine shown is a piston and cylinder. This is a cylinder, translation, and crankshaft is having a rotation like this, rotation, because this end is with R and the slider, this end is with translation. Now this connecting rod is having rotation plus translation. That means this body is having 2 degree of freedom, this body is having 1 degree of freedom, and this body is having 1 degree of freedom. That is the rotation. This is the translation. This is 1 degree of freedom. Translation. That's what. And this is a combination of translation and rotation, that is equal to 2. So this is how generally we will try to consider the dynamic case. Now the given problem, the piston rod, weight 45 newtons, crank radius 250, that is this one, weight is this one, and speed of rotation, that's what the speed of rotation is 120 rpm. Determine the magnitude and direction of acceleration. Now let us consider because it is rotating continuously 0 to 360 degrees, it is a simple harmonic motion. This one. X is equal to R cos omega t. Resolve the component. X displacement. R cos omega t. You know 0 to 360 omega is equal to 2 pi n by 60. N is given 120. 4 pi. This you differentiate. Further differentiate velocity r omega sin omega t minus, because cos omega t is minus sin omega t. Omega t differentiation is omega. R is constant. This is a constant. And this is a variable. Okay. So now this is how we will try to represent the equations. Now, if I draw the free body diagram, this is what is the acceleration now. Okay, the maximum acceleration is, find out the cos omega t is 1, that is minus r omega square. Okay, that is the maximum acceleration. Now we can use an equation. The standard equation is this, and this should be same direction. But in our case, this acceleration we got negative of this value into x. Why? Because these two are in the same direction, but it is acting in the opposite direction. That's why we got a negative value. From this, x is an unknown. Find out. Cos omega t, the maximum value is minus 1, minus plus, and this is what is the reactive force acting, 180 Newton newtons. Okay. So this is what generally we will consider. Now let us consider the second problem. A balloon of grass, note down the problem, otherwise this is given in one of the examination, comparative examination. It is there in Timchenko as an exercise problem, Timchenko textbook. A balloon of grass weight W is falling vertically downward with constant acceleration A. What amount of ballast load Q must be thrown out in order to give balloon an equal upward acceleration. This is a downward constant acceleration. But second case is what amount of ballast Q must be thrown. From here you have to throw the Q. Then we'll get, this is W, that is there. If you throw out, this is the component. So this is what is called the first case, and this is what is called the second case. Now substitute the given data in the problem. A balloon, gas balloon. Here some persons are sitting. Okay. So now consider free body diagram. Case 1, first case. Mass into acceleration equal to, because downward. This is the downward. Force is upward, weight is downwards. So now the mass into acceleration, this and same direction. So these two are in the same direction. That's what at W. This is opposite direction. Minus P. These two are in the same direction. P is opposite. That's why negative. Okay. So this is the expression is written here. W by G. This mass can be represented as W by G. Mass weight by G. Okay. So now similarly consider the case 2. This one. This is, both are in the same direction. And this is opposite. Mass into acceleration is equal to P minus W minus K. P minus W, mass into acceleration is equal to P minus W minus K. Okay. This is 1, this is 2. From equations 1 and 2, that is 1 and 2. This is not there. Now let us go to the next figure. Next W by G minus, this is the equation 1. This is equation 2. Same as what we got here. This is one equation. This is the second equation we brought here. Now solve, simplify, because we have to find out the Q value. What is the Q you have to find out from this. If this plus this is equal to this plus this, left hand side and right hand side. Okay. Now WA by G plus WQ by G and WP minus P minus W minus Q. If you can simplify that, we get Q is this. Okay. So this now generally we will consider the equation. This is one problem. You can represent Newton's law and D'Alembert's principle, but the result will be same. There is no difference in the result as per the result is concerned. If you are considering as a rigid body. Okay. Now consider this is another problem. Note down. A weight W 4450 Newton. A weight W 4450 Newton is supported in a vertical plane. Is supported in a vertical plane by a string and pulley. The string and pulleys. This is the fixed pulley and this is the moving pulley. Pulleys arranged as shown in the figure. Arranged as shown in the figure. A weight W 4450 newtons is supported in a vertical plane by string and pulleys arranged as shown in the figure. If the free end of the string is pulled vertically downwards, if the free end of the string vertically downwards with constant acceleration A, find the tension in the string. You have to find out tension in the string. Okay. Now draw the free body diagram. Before drawing a free body diagram here, because number of rigid bodies are there, here if we can find out, this is one tension, this is the other tension. Tension T, if there is no friction loss. Okay? Because the pulleys are, this is the moving pulley and it is a fixed pulley. This one. So that's why this is having x2 is the displacement, it is having x1. Okay? Or in other words, this is x2, this is x2, and this is x1. Or in other words, 2x2 plus x1 but if you can use some value, differentiate 2x2 dot plus x1 dot is equal to 0. Or in other words, x2 double dot to x1 x2 x2 plus x1 double dot is equal to p. From this x2 dot is equal to x2 double dot acceleration is equal to x1 dot divided by 2. What is the meaning of this is the acceleration of, if you take this one, If it is acceleration is A, it is A by 2. That's what here you can see. See now, if you can release the case, see now what we have to do is the tension in the string S, the tension in the string S, this acceleration is A by 2 and this, not this, this is A and it is A by 2. Okay, the previously derived. You cut it like this. Now this is the free body diagram, weight acting downwards. Now find out. Okay, acceleration is find out from the Newton's second law. Sorry, here actually this is A, means this is A by 2, not this. W by G mass into acceleration, acceleration is A by 2, mass into acceleration, W by G A by 2 is equal to in the direction of acceleration, that is 2s, and it is opposite, minus w. Now we take outside, then this is what is called the expression. Find out the unknown value. Okay, so this is how they will represent the expression. Then the here same tension is acting. This tension is equal to this tension. It is equal to A. So that the same value will get and find out the expression. So this is how we'll get the now note on another problem. An elevator of gross weight W 4,450 newtons. An elevator of gross weight W 4,450 newtons starts to move upward direction with a constant acceleration upward and acquires a velocity v is equal to 18 meters per second. Acquires velocity v is equal to 18 meters per second. After traveling a distance 1.8 meter, after traveling a distance, find tensile force S in the cable during its motion. It is a lift, an elevator of gross weight in hotels and apartments, etc., where we are using. Gross weight 4,450 newtons starts to move upwards direction with a constant acceleration, and angular acceleration is angular velocity is 18 meters per second. After traveling a distance of 1.8 meter, that is the input data. Input data is weight is given, velocity is given, distance is given, initial velocity 0. An elevator ground starts to move upward with a constant velocity and acquires velocity. This is the final velocity. Initial velocity starting from the 0. Distance traveled is now let us consider this is an elevator. It is a string. string is having a tension, yes, this is yes, weight downwards. See, that's why then expression is mass into acceleration. This is mass into acceleration. The acceleration direction is this here. In the direction of acceleration, yes, that is yes, positive, and this is opposite to this. That is the weight. Both are opposite. That's why a negative point. Now from this expression, S is equal to this, you move this side. This is the expression. This is what is the basic equation. Okay. So this is how generally we will consider any number of problems in the simple way. Now let us see a little bit complicated problem. Now here actually what is asked is find the tension in the S cable during the motion. Here A is an unknown point till now. Okay. Initial velocity is given, final velocity is given, distance is given, the acceleration is constant. See, because of that, we can use the expression S is equal to ut plus half alpha square of at square. Okay, because t is not given here. So now what we have to do, this equation is not valid. Now we have to use v square minus u square is equal to 2a s. Okay, v is given, u is given, s is given. That's what here x. Now substitute, find out the acceleration. That acceleration substitute. Okay. So this is how you can find out the expression. That's what here. V square minus u square is equal to 2as. From that find out the acceleration here, then substitute in the equation, find out the unknown parameter. Now go to the one more problem. A train weighing 1870 newtons without the locomotive starts to move. A train weighs 1870 newton without the locomotive starts to move with constant acceleration along a straight track, that is rectangular motion, and in first 60 seconds acquires a velocity of 56 km per hour. Kilometer per hour, if you can convert to meter per second, 56 into 5 by 80. That if you can simplify, you will get this. Now draw the free-body diagram. This is the acceleration direction, this is the force direction, this is the weight acting downwards, this is another force. Now mass into acceleration, W by G into A is equal to, in the direction of acceleration, this is the force, S, minus, this is opposite, F. This is the frictional force, mu times, frictional force is mu times normal reaction. This is what? Now that you can write an expression. This is how we will write an expression. From that find out. Here another data is given, acceleration we have to find out this value. V is equal to u plus at. The data is given. U, V is given. This is what? Time is given 60 seconds. Acceleration along it drop. Locomotive starts, acquired 60 seconds. See, that's why 60 substitute after MD. Okay. Now, this is what the total tension in the string you find. Now come to the another problem. A weight W is attached to the end of a small flexible rope. This is a rope tied on the disc. And is raised vertically by guiding the rope on a wheel. If the turned uniformly 2 revolutions per second, what will be the tension in the string? Okay. So if we exceed the initial radius of the wheel, time taken for n revolutions of radius wheel is n. Then find out the total radius is initial plus increment, or it may be decrement. Okay. See, this is what that we can find out from here. Then the acceleration is, you know, the expression acceleration is dv by dt. V is given already. And find out acceleration. Then apply equations. See, this is weight acting downwards. The tension in the cable is this. And this is moving upwards. From that, the direction of acceleration, W by G into A is equal to tension S, weight. S minus. From this, find out what is the value. This is the value. Final. Okay. Substitute the data in this expression. You can find out the value. So now let us go to another problem. A mine, case of weight 8.9 Newton, starts from rest and moves downwards with the acceleration A, which is constant, traveling a distance of 30 meters in 10 seconds. Find the tensile force of the cable. So this is the force in the cable, and this is the weight acting downwards. Now the equation is W by G A is equal to, in the direction of forces, there is W minus S. Okay. This is the expression. Now from this S is equal, because S is given, T is given, initial this is the time, U is 0, this is 0, this one, and from that substitute the data and find out the S in the case. With this, the rectilinear motion part is completed. Dynamics of a rigid body in a rectilinear or a curvilinear motion. So now let us consider the rectilinear motion is completed. Now let us come to the curvilinear motion. Let us consider VA the tangential velocity. In a curvilinear motion, we can represent in x and y like x and y, or tangential normal. You can consider any direction. Tangential normal like tangential or normal. See here the tangential velocity is A and tangential velocity of B. If you can consider VB is equal to V, this is the velocity. dV is equal to V d theta, there is no normal velocity. This can be represented as dV is equal to V d theta. V into d theta is equal to, see, V is equal to ds by dt. This ds is the ds, r into d theta. So that's why ds is equal to r into d theta. Okay, that if you can substitute, we'll get acceleration. This d theta is ds by r. If you can substitute here, v into ds, then dv by v square, if you can simplify, and normal acceleration is equal to v square by r. This is the expression what we are going to get. See, now let us consider the acceleration of normal, the magnitude of equilibrium applied normal acceleration is v square by r. This one is the normal acceleration. Okay. Now let us consider the one problem in the curvilinear. Before going to that, suppose in a curvilinear motion, a point is represented a curved path. This is x, and this is y, and this is the normal, and this is the tangent. Okay, we can represent x and y axis. We can represent normal and tangential direction. Okay, when you are representing x and y, this is the normal, this is the tangent. That means summation of forces in x direction is equal to mass into acceleration. Some other forces in y direction is equal to mass into acceleration in y naught. Okay. If you resolve the forces in x direction and y direction, these are the equations. Suppose if we are resolving forces in normal and tangential, in that case, sigma f normal is equal to, or otherwise capital N, is equal to W by G into normal acceleration. This component will come into here. Or sigma f tangential, this is equal to W by G into tangential acceleration. That means you can consider any combination. Either this combination belongs to x and y, and this combination belongs to this. But the condition is either this or this. Only one only you have to select, not both. That means resolve the forces. Why? Because the curvilinear motion is having x degree of freedom, y degree of freedom. X, y. Two translations. Okay. But sometimes instead of x and y, you can resolve along normal and tangential. That also we can find out. See, this is how generally we'll try to consider when the body in a curvilinear motion. See, the translation is a rectilinear motion and a curvilinear motion. The rectilinear motion is having 1 degree of freedom. The curvilinear motion is having 2 degree of freedom. Okay, that is translation in x, translation in y, or normal and tangent. So this is how generally we will consider the curvilinear motion of a particle. So now let us consider the automobile from rear side. This is the CG moving on a plane track. These are the two tires, vertical reaction. This is the net frictional force due to combination of two reactions. With this as a center, it is moving. That is a curved path. It is generating like this, the path. Okay. It is moving on a road like this. Like this. It is going. So now what we have to do is, we have to consider now the equation. This is the direction it is traveling. Mass into acceleration is equal to centrifugal force. Because this is when it is moving in this direction, the acceleration is away. Centrifugal force is toward the center, along this axis. So that's why this is mass into acceleration. Acceleration is v square by r. So now what we have to do here is, mass into acceleration is equal to W by G into v square by r. And that is what we have to consider. Now the force, one force is acting. You have to go with that initial frictional force, and this is the initial force. Okay, F is equal to mu times W. This mu n, now we have to equate. From that, if we simplify, this is the V square, can be represented as GR. This W vertical reaction is equal to R1 plus R2. Okay. If by symmetry both are same, R1 is equal to W by 2. Okay, that's what from this expression, it is equal to N reactions. The N is nothing but this one. N is W by 2. Okay. This mu N, mu W by 2. That if you can simplify, GR, W if you can equate, W will cancel, mu is a coefficient of friction, this is the mu, velocity, in terms of friction we can find out the expression. These are the, you can find the values. See, now let us see it is a curved path with an inclination alpha. The speed and angle of braking, desired speed and the angle of the braking. Now if you can see, this is the force we have to resolve. This is the W acting downwards. This is W cos alpha. This is W sin alpha. This mass into V square resolve along this axis. This into cos alpha and this into sin alpha. Okay. Now as far x direction is concerned, the initial force W by G V square cos alpha is equal to, in the direction of force it is positive, but it is acting in the opposite. That's why minus W, because this is equal to this initial force, D'Alembert's principle. So W by G, this is the opposite, W sin alpha equal to sum of the force equal to 0. It is positive and it is negative. I applied initial force, a centripetal force. Actually, when the vehicle is moving, it is away. Tendency is away from moving. But I am applying it towards opposite. That is what the initial force. W by G V square and apply this in the opposite direction. Like this is the initial force. You apply like this, tangent. Okay. So this is how we can resolve the components and resolve the forces. From that, cos alpha by tan, sin alpha, tan alpha is equal to V square by G. But here, in this case, the initial force is acting in this direction because of centripetal force, initial force. And this W cos alpha acting opposite. This is the negative direction. This minus this. Fi is this along this axis by making an angle. And this is the negative. Minus is equal to 0. See, from this weight and weight will be cancelled. Now tan alpha is equal to V square by Gr. This you move this side. Tan alpha is equal to. So this is how generally we can write an expression. Now condition of skidding and overturning. These are the two more conditions we'll get in the analysis: skidding and overturning. Okay, same previous problem only. In this direction, it is times cos alpha, whereas this is W sin alpha. This is the frictional force F1 and F2. Two reactions R1 and R2. The centroid distance from the plane is h, and this is what is alpha. Okay. So this is how we will try to consider the problem. Now let us consider what is the skidding and overturning. The condition of skidding is can be get this mv square tan. If you can consider the expression, this is alpha with some the same alpha here. Okay. And some angle of tan phi mu, coefficient of friction, is also coming. Earlier we have not considered this. In the previous problem, if you can see, no frictional force. There is a chance of skidding. Okay. So now what we have to use, we can consider the frictional force is equal to mu times the R, or R1 mu times F1, or F2 is equal to mu times R1. So this is what is that. To avoid skidding, we have to consider this. See, that is an extra component which is coming. The tan theta is equal to mu. Instead of tan alpha, the same expression. V is equal to mv square tan total phi is equal to mu. That means W by G V square by R along this axis. Then the net force is equal to mu times W, mu times N. Okay. With that, if you resolve along plane. Now, if we can consider this and resolve the components, V square is equal to mu G R, or V is equal to under square root. When in a plane surface, but it is an inclined surface. If you resolve mu, this is a mu tan phi. The phi is nothing but mu is equal to tan phi. That is V is equal to square root of mu G R. G R is same. That's what. Only that angle tan alpha you have to consider the total angle. This alpha, if this you resolve along this axis. Okay. Then F1 here. This is also alpha. This is also alpha. If you resolve along this axis, you will get the effect of alpha. Okay. Condition of overturning, the limiting speed from consideration of overturning can be get by considering this height. this is what is called height. This is the base. This is the height and this is the base E. From this find out it is alpha again. And from the geometry, if we can use, this is what is the H, E, GR, and that parameter will be considered. Same velocity under the water turning case. That is less than or equal to, if you can consider, mv square by r less than or equal to mu r. If you can consider that, we'll get the condition. Okay, this is how the water turning can be get by considering the forces. So now let us go to this is what is the curvilinear motion in a plane surface. Now let us take a small problem. A circular ring has mean radius r 500 mm and made of steel, for which W is equal to 70.1 kilonewton per meter cube, for which ultimate strength tension is equal to 41.3 megapascal. Find the uniform speed of rotation about a geometrical axis perpendicular to the plane of the ring at which it will burst. Okay, this is the angular velocity, this is the weight, the gravity and the density, Newton per meter cube, density. The mean radius r is given, tension is 41.85 megapascal. That is the given data. So now what we have to do is we consider a circular ring. This is the circular ring. Cross section with respect to this is d theta, like this. This is the section, and this d theta is substituting here. Find out the small centrifugal force acting, that is mass into velocity square. Mass is, this is the dW. Mass weight acting down, double mass mv square, m by g. Small, where A is the cross sectional area, P the tension in the string. This is what is the P, equal and opposite. Here, P. The P is tension, that way if you can consider tangentially. So now that's what we will show here. The weight of the element is equal to weight into volume, the density into volume. The volume is ADL and this is the mass density. It is given as an input. Now integrate, substitute here this mass and this is the velocity, v square by r. We substitute mass into v square by r. This is what is the initial force, and I used this expression here, v square into the remaining part. The same thing, the dl r d theta. This what? That is the final expression. And the braking force along the 2p. 2p is this. P is sin theta and p cos theta, p cos theta, p sin theta, 2p sin theta. This is what is the 2p sin theta. Now equate for a small angles, it is equal to 2p into d theta. Okay, equate these two. External force and that is the centrifugal force. If you can equate, you will get this is what is the load P and stress is equal to load by area. From this substitute V is equal to pi dn by 60, find out the n value. This V you can substitute as pi dn by 60, find out the n value. Okay. So this is how generally we try to apply for a ring is having the problem. So now let us consider the plane model. The general dynamic equation consists of a rotation. Consider the body of small mass disk with an angular acceleration alpha at a radius r from the center. R from the center. Okay. Now force is equal to this. This is what is the tangential force. Force is equal to the tangential acceleration into mass, m into a, mass acceleration. Okay. But tangential acceleration is r into alpha. R into alpha. That if I can substitute here in this expression, R is constant, let us say. See, the moment is equal to here. Moment about this point is equal to about this point. This force multiply with the perpendicular distance, because dp into r. That if I can substitute here, dp into r. The delta p is delta m into, this is r alpha and delta m. Okay. And now what we have to do, delta m is equal to delta p into r. Delta p can be delta m into r alpha. Delta m into r square into alpha. This is what is the moment. Now the total moment is equal to the summation of all the moments is equal to, this is the summation of, that means add this summation. That is equal to the total moment, and this is the mr square. This is the mr square. That is mass moment of inertia. See, that's what the expression, and find out the expression. This is what we can find out the given situation of the system. Okay, this is how generally we will determine mass is equal to I alpha. Now let us consider a cylinder, one problem. A cylinder weighing 5 newtons, this is 500 newtons, is welded to a long 1 meter long uniform rod of 200 newtons. Okay, this what? Tangential acceleration. R alpha, tangential acceleration. Mass into acceleration. Acceleration is R alpha. Not normal. Normal is in this direction. Because it is rotating. Rotation only will consider tangential acceleration. Or curved path, we have a normal and tangential. In curved path towards center it is acting, we will consider normal acceleration. When the body is in a rotation, we have to consider tangential acceleration. Okay? See, when it is in rotation, about this axis rotation is taking place. Okay? See, now what we have to do is, we have to consider the weight is acting downward, that is towards down. This is the tangential force when it is in rotation. That is the data given to you. Determine the reactions at A. This is a pin joint. Find out the vertical reaction and the horizontal reaction. You find out both. Vertical and horizontal reactions you can determine and find out the this particular one. So now let us consider. See, this is what is the center of gravity G. This is IG. This is, let us say, A, and this is B, and this is G. Okay, the mass movement about this axis, mass movement of inertia about this axis, about this as a center. We are use the parallax theorem, mass movement of inertia. See, that's what here. See, if you can see, this is what is the. This is the D1. This is the D2. The total distance. 1 meter, 4 meter. This is the center of gravity midpoint. Point 5, 0.5 up to this plus 0.2. Okay, 0.7. These are the distances are given. Now find out the mass moment of inertia of a bar A is half IQ mv square. Now, dear students, there is a small network problem. So now let us see. This is where we have a cylinder weight. Here the weight, this is what is the axis, it is rotating about this axis. This axis, as far this bar is, let us assume that there is no cylinder connected. This is a slender rod, about this axis it is rotating. The moment of inertia about this particular point, you have to find out this value. And mass is acting at the center of gravity, the total mass, that is md square. Okay, so that is what is the first equation, the first part Ig, mg R square ml square. 1 by 2 ml square is the moment of inertia passing through the point axis of rotation. This is md square, mr square otherwise. R is 0.5. The total length is 1 meter. Okay. Similarly, the mass moment of inertia of namaste. హాస్పిటల్కి తీసుకుంటాం అలా అది లేయర్ ఉంది క్లియర్ చేసుకున్నాడు ఓకే ఓకే నాకేదో నోటీస్ ఇచ్చాడు అలాగే మాయవాడ ఫోన్ చేసి మాట్లాడారు డబ్బులు వెంకటరావు తీసుకున్నారు వదిలేసి డాక్టర్ గారు క్వారంటైన్ తీసుకోవడానికి జిమ్నేటి మీద కేసు చేశారు అందుకే నిద్ర తీసుకోలేదు అన్నారు ఓకే See here, what we have to do is, here we have to count to M1 and M2, moment of inertia of the first mass, that is the rod, and the cylinder. The cylinder moment of inertia is again half mr square, and this is what is the distance square. You find out this is what is the moment of inertia 1 and moment of inertia 2, then MT is equal to I alpha. Moment we have to take is equal to I alpha. I alpha is I is this, alpha you have to count, and this is moment. Moment about the axis, about this point, mass of this into perpendicular distance, mass of this into perpendicular distance. That is 1.2 into this 0.5 into 200. So this is how we will consider 700 Newton meter. This is what alpha is equal to, m is known to you, I is known to you, m by I, m is 700, I is 74.4, and find out the, then instantaneous acceleration is equal to R alpha, tangential acceleration, R is known, now alpha is known to you, R alpha, similarly R1 alpha, R2 alpha, that is the radius. Then find out the reactions. Applying D'Alembert's principle, the reaction horizontal force. Horizontal force is equal to the vertical force, horizontal reaction, vertical reaction. You can find out the moment is equal to this 700 and now this is what 200, 500, that reaction. Mass into 4.31 R alpha, R into alpha, mr, mg into m, that is weight, m by g, weight is equal to w by g into R alpha, the first mass, second mass, one is acting towards the, one is here, if you can see here, this acting this direction, this is acting in this, that's why if it is positive, obviously it is negative, okay. This is what the positive and it is a negative values, and find out the total reaction. So this is what generally we will asking the problems. This is a general mg is equal to ig alpha into mrg, that is it, into acceleration of that particular, or in other words, parallax theorem, I alpha. I is mass moment of inertia passing through this x into ig plus mrg square, the distance into alpha. Consequently, we can write three equations of motion: normal, that is normal, the resultant of this force system, tangential, and moment. Moment is equal to I alpha. So this is how we can determine MRG. Normal is equal to R m into normal acceleration R omega square, m into tangential acceleration R alpha, and m is equal to I alpha. Moment of inertia passing through the hoop. Okay, the three component, because it is a plane motion. It is a, this is the, earlier we considered rotation, now it is a plane motion. Plane motion consists of two translation equation and one rotation. Rotation, earlier we considered the rotation. In the previous case, this is the only the rotation we have considered. MT is equal to I alpha, the rotational part. That's what. Now include the translation and rotation. That is the plane motion. Because plane motion kinematics also we have not discussed much. That's why this topic we will discuss separately. But I am giving only the concept. The three equations: normal, tangential, and moment. Moment about a point. I into alpha. Okay. So this is how generally we will consider some other portion n is equal to 0, some other, if suppose a static system, no dynamics. This can be considered the normal tangential, or this can be considered x and y direction, depend upon the choice. And the moment is whether it is a normal and tangential x and y, it is about the origin only. It is same. So that's why you can consider f is equal to w by g into ax, the x, w by g into ay, or w by g into x double dot, w by g into y double dot. Moment is equal to I alpha. Okay. So this is how generally we will consider and solve the problem. This is the plane motion of your body. See, with this, now today we will today mainly what we have concentrated is dynamics of a rigid body. Okay, that means dynamics is the rotation, translation, and plane motion we have considered. This, and it can be a combination of translation and rotation equation. Plane motion also, the concept is given. Yesterday also we discussed this relative velocity method. But in detail about a plane motion we will discuss later. That means today the dynamics of a rigid body in a translation, in a rotation, in a plane motion we have considered. And how to represent D'Alembert's principle, briefly we discussed. And what is the momentum impulse principle, what is the Work-Energy principle. Okay. But today mostly concentrate on the how to write an equation of motion for different cases. For a body in a translation, that is a rectilinear translation and curvilinear translation, the body in a rotation, and little bit concept of plane motion. Okay. Tomorrow we are going to discuss the same thing, how to solve the problem by using D'Alembert's principle. Or subsequent classes, work energy, moment impulse. That means the same problem can be solved by using any of these. You will get the same equation, same result. But depend upon the data given in the problem, you have to determine what type of equations we are going to have. Okay. So with this, If you have any questions regarding of any of these, either translation, rotation, or plane motion, then the translation, rectilinear, curvilinear, and rotation. Plane motion, we will go discuss some more aspects. Regarding these three, with reference to kinetics and kinematic analysis, if you have any questions, please send your queries through Google Forms and we'll give a reply. Regarding the lecture speed or slow or whatever the problems, if you are facing anything, if any suggestion, please suggest, because online tools have different web connectivity, different capacity of, there is a speed. It may be a lot of problems, but if you can send your feedback, it may be more useful for us to improve further class to class. Okay. Have a nice day. Thank you very much for your patience. Thank you very much.